about the guided random search technique under the evolutionary algorithms, which is the genetic algorithms. That is our main focus for today, which is the genetic algorithm. So what is a genetic algorithm? It is an algorithm that selects randomly of an element to produce a successful successor. But in this algorithm, we are dealing with sexual reproduction, which is the gene itself. So as I mentioned earlier, this algorithm is a guided search algorithm based on evolutionary process. But before that, what is evolutionary process? It is a change of elements that relies on natural selection, which relies on the best traits. Let's proceed to the operations of algorithm. The first operation is the chromosome representation, meaning to say we are giving the names of the chromosome by using a binary code which has a 24 bits. In this example, there are 4 empty boxes which we have to read it from the right side to the left. So the first box is 2 to the power of 0, second 2 to the power of 1, 2 to the power of 2 for the third box, and lastly the fourth box is 2 to the power 3. But when you power it up, 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8. And surprisingly, after you sum it up, it will generate a 24, a sum of 24. So here we're getting a 24 bit. Question. Refer to the notes that Dr. uploaded in the eLab. It shows that the question asks for a parameter of 0 to 15. So here, we only can put an integer, which the number is between 0 and 15. So first, let's say I want a parameter of 14. I will actually put 0 at the first column. Second is 1, which will be 2. The third one is also 1, which will generate a 4. And lastly is 1 also, it will generate 8. So when you sum it up, it will become 14. So here in this box is your chromosome representations. Or you can say it's the chromosome string. And this one is the number that you decode, or you change it to the simplest or the understandable number. So after you name the chromosome, you have to choose the size of population, probability of mutation, and probability of crossover. So the second operation is initialization. First, you have to define the fitness function of each chromosome, which will be explained in here later on. And secondly, note that the initial populations are selected randomly. So, back to our define of fitness function. Again, refer to the slide uploaded by Dr. in eLab. It stated that the function is 15x minus x squared. So, since our parameter is 0 to 15, so we have to substitute every single number of x, which the parameter is 0 to 15, to find out the fitness, which is the fx. So here, I already substitute that. If 15, x I substitute 1, it's x substitute 1, power of 2 is equal to 14. So I plot here 14, and so on 2 will be 26, 3 will be 36, 4 will be 44, 5 50, 6 54, 7 56, add 56, 9 54, 10 50, 11 44, 12 36, 13 36, 14 14, 15 0. In this initialization is to find the maximum value. So here the maximum value is x is equal to 7 and 8, which will result in fx equal to 56, or the functions, which result the fitness is equal to 56. After you calculate the fitness, then you have to calculate the fitness ratio of each chromosome. So here I had chosen or initialize 6 chromosomes, which I name it X1 1100, X2 0100, and so on. So these are the decoded integer. How do I get this? Remember, binary code, you have to start from the right to the left. So 0, nothing. 0, nothing. So this one is actually 2 to the power of 4, which is 4. 2 to the power of 3, which is 8. Add plus 4 is 12. Same goes to this. It's 0, 0, nothing. So this one is 2 to the power of 2, which is 4. Same goes to the others. So, chromosome fitness, where do we get this? It is from the function that we have calculated earlier on. Now, our main focus is the fitness ratio. How do we get the fitness ratio? So firstly, you have to add up all the chromosome fitness that you have initialized, which is the 6 chromosome here. And second, select the chromosome fitness to be calculated. This means that if you want to find this fitness ratio, you have to divide it, chromosome fitness over the sum of chromosome fitness. For example, I will choose this X5, which X5 chromosome, which the chromosome fitness is 56. So the sum of chromosome fitness that I have added up is 218. So now you have to select your chromosome fitness and divide it with the sum of the chromosome fitness, which the answer will be 25.7. And same goes to the others one. If you want to find this fitness ratio, you have to divide 36 with 218, 44 with 218, we generate this, 14 over 218, we generate this, and so on. In natural select, the third operation of algorithm is the natural selection. Here you have to select the fittest pair among the selected chromosome. In this 6 chromosome, the most fittest among these 6 chromosomes, the X5 is the most fittest among the 6 chromosomes. So that means this will generate, or this will have a better or successful successor when both parents crossing over their genetics. After the natural selection, the fourth operation is genetic crossover. Here, we'll be using the roulette wheel selection. That means it will be randomly turned for 6 times because we have a 6 chromosome here. And the point of crossover between the 2 chromosomes are random. And we'll generate, or we'll have, a 2 new offspring. Let's say that this is the 6th chromosome with a binary code or chromosome string 1001. This last 2, it cross over with the last 2 of the X2 chromosome. So end up the X6 new offspring will be 1000, while the X2 will be 0101. Same goes to this. The 3 boxes here exchange with this will generate a binary code of 1111, while this 0100. The fifth operation is a random mutation, which is to ensure that the search algorithm will not be trapped on local optimum. Sorry, here I should not say not trapped. So, here, for example, X1 chromosome with a binary code or chromosome representation or chromosome string with 1111. For this, the third boxes is mutated will be equal to 1011. So it's actually become, if the 1 is mutated, it becomes 0, and vice versa. If 0 is mutated, then it will be turned to 1. Lastly, the 6th operation is the stopping criteria. So, what is the criteria to stop this algorithm when the size of new population is equal to initial population? Which means that after that, you have to replace the initial population with new populations. Remember, after you do the new population, you have to recalculate the fitness of the populations. For example, these are the final chromosome string, and this Fx is actually the final fitness for the chromosome. So here, let's say I already have the chromosome string with 1000. So how to find the fitness? So you can actually substitute the x. Remember the function just now is 15x minus x2. So you have to substitute the x with number at for x1. How do I get this at? Remember binary code starting from right to left. And if it shows 1, that means I have number. So here is actually 2 to the power of 3, which is 8. And here 2 to the power of 0 is 1. Here 2 to the power of 2 is 4. So 4 plus 1 is equal to 5. So 15 times by x, which is later you substitute it equal to 5 minus x power of 2, which will be 15. 5 minus 5 power of 2, which the answer is 50. And same goes to the others. And this cycles or operation is also known as a genetic algorithm cycle.